Hello, how are you doing? Hi everyone, hope you doing good. So we are going to, good to know. I'm good, thank you. And I appreciate your adjustment. I was not able to hold class on Tuesday. I had a board presentation. We did pretty good for the study abroad program. So today we're going to go over the assignment. We no longer have additional labs for this class. So I want to let you know that you can start preparing for your project. And we have a couple of things left to cover from the book, kind of also review some of the concepts. So if you can take a look at your notes, which is in Unit 11, I'll share screen shortly. And then we're going to go over the assignments together. So this week we're going to talk about functions. We're going to compare the functions in C and how that translates to subroutine in LC-3. So the chapters that we're going over is going to be 14 and 16. We're going to talk about functions, pointers, and array. As some of you will be interested in implementing arrays for your project, right? We'll talk about how to be able to write array in LC-3, also how to use pointers. I know that sometimes when I teach C++ class or when I taught C++ class, students always struggle with pointers or even writing functions. So let's talk about function in C. And as you know, C is a strongly typed language. So when you declare a function, you have to put in the type. And that's going to allow it to allocate memory for the function along with having the proper return value for that particular data type. So in the example that you see on page 1 of your notes, we declare the function and prototyping it using the data type int for integer. And that's going to allow us to return the value in whole number. And in this case, we are writing a function for factorial. So you would have the name of the function following the data type. And then your argument is going to be inside the parentheses where this is going to be also typed. So we have to put in the type and then the variable that we want to pass into the function. So this is where your argument is going to go. And the difference between the prototyping and the definition of the function in C or C++ is that you would prototype to let the compiler know that this is the function that you're going to use, whereas you are going to define the function where the body of the function is going to be including the task that you want it to execute further along in your code. So this would allow us to be able to use the function and execute a certain task. And in the notes, it talks about how function is an abstraction. Basically, it is a way for us to be able to control how the program execute. And you can incorporate different areas like for C programming or C++ in particular, we can use class objects and also be able to implement member functions in the classes. So that way you can control some security end on that and how it accesses the class. But ultimately, when we look at the function, we would use the function as prototype and define. And when we need that function to be executed, we would have a function call. compare this to LC3, you would see that LC3 uses subroutine, aka function, right? So it would be a function equivalent is a subroutine. But in LC3, we would start the call earlier on in the code as you would jump to subroutine, where in C or C++, you would see that later on in the main. So you would build the function definition at the beginning, and you would define that in your code. Then in the main section, you would then call the function on when you want it to execute. So in here, it gives you the step that when the function is called, it's going to take a look at your arguments, what you included in the arguments. So it evaluates the argument. Then the compiler is going to execute the function, and it's going to return the value. And so we always want to return from a function, right? The function's job is to be able to complete a task and return from that task. And so when you define a function, again, you will include the type of that function here, and you would give it a name. And we talked about how we would have the argument. Inside the body for C, you would use the curly brace. And in it, you would want to incorporate maybe a loop, some variables. Now, in the case where we use local variable, like int result here, right? Int result is going to be localized to that particular function. Whereas if you use a global variable, when we define that earlier on in the program at the beginning, we would be able to use the global variable for multiple functions. So in this case, the int I and int result is used within this function. So it is local to that function. So outside of that, it doesn't exist. And for our program here, what you see is you want to have a for loop. So here we have a for loop. We would start at 1, and we're going to go up to n, and we're going to increment 3 parts in the for loop. We talked about that last time. And in the result, we want to take the I and we want to multiply it by itself. So every loop, it's going to be using the operator, right? Multiplication with the equal, where you would be using the I multiplying by itself and then return the result as it does it. So when this function is called, your return value is going to come from the result variable. So for our question, we would start with explaining the purpose of a function in C. So we can take what's in the note. We can say that function really gives us an abstraction, and it hides the low-level details. But in subroutine, we work directly with the instruction for the low level. So that's the difference. And the compiler for C handles, right, the low level, whereas the function itself is a high level definition. So it is a high level structure to the program. It allows the programmer to control the program flow, and therefore we can implement loops. And in our case, in LC3, that will be branches. And it would allow us to enable separable independent development, where you can have one function to do one task and another function to execute another task. So function ultimately is a way for us to achieve specific tasks. So I can have a function to obtain values from the user, right? And in that, for C, we would have cin, and we would store it into a container like a variable or array. So we can name that get value. And I can have another function to display what the user input. So I would take what was stored after the user entered, right, into a container, a variable, an array, and I can create another variable to display the values that the user entered. So you can have separate tasks that's achieved in your program through functions. And so previously we talked about stack, and so let's address stack shortly. Do you have any questions for me regarding functions? Okay, so here there's some additional information about writing a function in C. And we would know that the function call for C exists in the main, so main calls function, right? And main itself is a function. Now, when you work with Python, right? Python, you can have a main section, but usually the call is at the end of the code. So there is a main, so you can also use like if main, right? Then you can call the function, or if you just have a function call at the end, it would know. So the interpreter works a little differently compared to C compiler. And so the example, you can see the example here, how we would prototype a function or declare the function. We would call the function and we would define the function. So traditionally, this is what you see in the program, right? We prototype at the beginning, we call, and then we define at the end. Now in LC-3, it is a little reverse in that you would do the jump to subroutine at the beginning, but you do define your subroutine later on. It depends on the type of label that you use, or how you want to define the label. So usually we just go to the label and be able to add additional instruction as part of that subroutine. So we would use a label for that subroutine name as how you would use the name for your function. So when we implement the function, we already talked about the arguments and the local variables, but you need to understand what's happening in the background with the processor. And so the compiler handles the low level. And so when you implement a function, when you define that function and that function is used to the function call, your arguments, which are normally your variables, and other local variables are going to be put into what's called an activation record. So think of this as like a file or a part of the stack that's going to use to be able to acknowledge or see what variables that you use, or arrays even, right? Containers that you use in your function definition. So all of these things get pushed onto the stack through the activation record. And during the runtime for the stack, it's going to use what's on the activation record for the function call. Any question? I heard somebody earlier. So when you're looking at the call function, what you see is it's going to execute the code, but how does it know what kind of arguments you're using, or the variables that you define locally to that function is through the activation record. And as it does that, it's going to pop the activation record off the stack before it returns. So it's going to free up that space. And remember, we talked about how stack growing downward. So as you have, let's say, many function that you define and you call those function, the activation record is going to get put onto the stack. And as it calls the function, or as we call the function is called. And as it's using after it's using the variable, the local variables and the arguments, then it's going to pop it off the stack and free up that space. So your stack shrinks back up. And then it's going to do the return value. So we have to understand the mechanism of how the function is called and how its relationship with the stack to really understand how we would handle it on the low level. And this is why we go over this. So in the next section, it talks about the runtime stack, and it says that when you have the function call, just what we talked about, your local variables including your arguments, is going to get put onto the runtime stack through the activation record. And so in LC3, what we do is we would use a register to be able to point to that activation record. And traditionally, by practice, we would use register 5. Remember that when we talked about stack, we use R6 or register 6 to point to the top of the stack, what value it is at the top when it was last pushed in. Similarly, you would have a register that's going to point to where that activation record is on the stack itself. So we would use a register to be able to point to the activation record, which contains your local variable for that function. So that way it would know how to be able to retrieve the value at that location to be able to plug that in and execute the task. And after it's called, it's going to pop that off. So those values or those container gets popped off, right? And so this is what you see before the call, right? And then you just have the main. And then after, so as it's doing the call, you're going to have your stack growing. So you're going to have R6 is going to point to the top of your stack. And then R5 is going to point to the activation record in the stack. And then after it's called, right, it's going to pop that off. And so we're back to main again. So we have to think about this when we write our stack and use our subroutine. You've seen this in your last lab. Okay. So for your activation record, it would look something like this in C, right? We see that there are arguments and then your local variable. This could be WXY, and we want to return Y. So the job of your activation record is to really keep track of what's defined in your function. So it does bookkeeping. And so when you look at the memory allocation for your function being called, we have the W, X, Y. Those are the local variable. They get added to your stack. So that it will be right here. And so with that, your R5, your register 5 is going to point to the container or those variables. And so it's going to have the dynamic link, and we'll talk about that, and then the return address and the return value. And in LC3, we know that when we do the RET, that's really associating register 7 to the address of the values that's being returned, in this case, Y, right? And then your arguments, which is int A and int B in this case, inside the parentheses here, that gets added to the stack too. So in the activation record, think of it like a file that has a table. It's going to be like this. It's going to have the name of your variables and your arguments. It's going to have the type, the offset, right, and scope. And so ultimately, it's really a way for us to be able to retrieve data from one location to another, right? And then to bring in the data to a separate location where it's going to handle the compiling. Any question? Okay, so let's go back and answer number 2. Describe the process in runtime stack when calling a function and after it's called. Right, so we can say that when the function is called, the activation record is pushed onto the stack. And we already talked about the content of your activation record. And after the function is called, I should say here, when it returns, its activation record is pop off the stack. And so it would give back that space, right, to the operating system or to the system. And then it's going to be back to main if you're using C. So at this time, we should understand how stack is used for function call, right? And what stack is, we already established that last time. Any question? Okay. So with that, we really have to kind of dive into what is the return value, what is the return address, and what is dynamic link. In the next section of your notes, and also number three asks you to describe the functionality of return value, return address, and dynamic link in the activation record bookkeeping process. So a return value is a space, hence memory space, where the value is being returned by the function. That's where it's stored. And this space is allocated even if the function does not return any value. So when you define a function in C++, and even if you're not returning from that function, that space is included in the activation record with the stack. And the purpose of writing a function is to return from that function. So therefore, it's really important, right, that we think about how or what type of function that we create. And so where is that, right? You should ask, how can we find this return value? And that will bring us to the next part, which is the return address. So the way that it works is that it's going to have a pointer. So it saved the pointer to the next instruction in the calling function. So once it locates the address for the value that's returning. So in the example, I have return Y, right, in the notes. Then for that, it's going to save, it's going to use a pointer, and in that, it's going to point to the next instruction for the calling function. So when I jump to subroutine, I have to think about after that subroutine is called, right? The simulator, it uses the R7 to be able to point to the next line of your code, the next instruction. So when you do RET, return the value, then R7 is going to be storing the address of the next line of your code or the next instruction where it's going to use. So in the case if I do JSR multiply, return, JSR divide, return, then what I would have is I would see that process in having a return address where it can go back and be able to call the next function in line. And then the third element of your activation record is your dynamic link. This is considered the caller's frame pointer, and it uses this to be able to pop the activation record from the stack. So it is a pointer that we would use to reference where it's going to pop the activation record in the stack. Without dynamic link, we cannot pop off the actual activation record. So when you look at the notes, right, and you can find all of this here, you would see the illustration on the right, on how we would compare your C to your LC3. So your dynamic link is where that's going to use to be able to eventually pop these off from your stack. And again, the answer for that question is on page 3 of your notes. Any question? Okay, so let's take a look at this example. So you have a function called volta. These are your arguments int q and int r. And then we have a couple local variable int k and int m, and there's additional code here, right? Remember that these are snippets. So we only highlight some of the major area where we would reference the activation record. And then for my function, for this function, we want to return k. And then we have the next function called int what, and arguments is a, local variable is int w. And then we would have, it would do something to calculate, right, volt to watts, and then return w. So when we call the volta function, right, it's going to have to push these, right, as part of the activation record onto the stack. So when in specific, when we're looking at just the argument itself, because that's the first part, right? When you see your R and your Q. So your R and your Q is going to be there. And so what it's going to, we have to clear register 0, right? And the argument here is 10. So we would take 10, add it to register 0, put it on register 0. And then we have to move our 6 down by 1 by subtracting it. So when you subtract 1, what's going to happen is the R6 is going to move downward by 1 because it has to go from the 10 to the 25. The illustration is backward, but think of your memory array downward. So we are going, when we subtract 1, it's going to point to the value, which is Q, 25. And then it's going to, we have to store. So do a store. And remember what we established when we store, it's like copying from one register to another. And then it's, we have to push the argument on. So we have to use register 5 because that's for the activation record. So you have to load 0 to register 5 and put it on register 0 because that was the register that we used for the argument. And then again, we're going to subtract 6. So, I mean, subtract 1 from register 6. So that way it's going to move down 1 more. And then we're going to store. Okay. So this is part of how we would write it as arguments that would go on the activation record. And then we would jump to subroutine. And return. So it didn't show, it didn't illustrate the return part, but you would get the R7 as we talked about that before. Now, this is for calling the function. And so when you're looking at the callee function, what you would see is when we subtract the 1 from the R6, basically we are repointing it to the next location. So when it's returning, it has to move down 1 to the return value. So if I'm returning W, it has to go to the next address in the memory array, which is where we subtract 1. We move R6 by 1. So that way it could retrieve the return value. then it's going to push the return address. So subtract 1 again, which is the next location for the return address. Then we are going to copy or store register 6 to register 7, because register 7 is where it's going to go to get the next function call. And then we have to do the dynamic link. So your frame pointers is going to be subtracting 1 more. So as you move along, you notice the pattern, right? We're going to go so we start with R6. We're going to subtract 1 to go to the next location. And then for the next part, it's going to subtract 1 again. So for the dynamic link, we are going to, it's here. We're going to subtract 1 and then we store again. So every time that you adjust your register in the memory array, you have to store it. Otherwise, you have to copy it between the registers. So it updates register 5. Otherwise, register 5 will not know, right, how the activation record changed. Okay. And then we would add -1 to R6 and then put it on register. So this is going to create the next location for the activation record to pop. So if you're able to visualize this, right, our R, our Q, our W gets added to the stack. The last one that was added was the Q, so R6, right? And then when we call the function, it needs to access this and this. So after it accesses this, we have to move it down, right? And then we also have to adjust the activation record, which is register 5. So that way the dynamic link will also be updated. So as it uses it, we have to also pop it up. So, and your stack is going to shrink and grow periodically depending on how you call and when your function is called. So let's talk about the process for the subroutine. We already talked about how the caller is going to push the arguments, and that's from the activation record. And it's going to be last to first, because for your stack, it's last in, first out. Right? So the last one is going to be on top, and then your first is going to be the bottom. And so because the last one is going to get pop off first, so if you have 2 arguments, the last one that's going to come in is going to be on top. So last to first. Then when we call, the caller is going to invoke the subroutine. So we do a JSR here. And then after we call, right, we want to return a value. So it's going to allocate. So that means that we have to move the register to the location of the return value. So we have to subtract R6 by 1 to move it down. And then that's going to be where the return value is going to be located. But we need to get the address. So we have to push R7 and R5, because R5 is in charge of our activation record and dynamic link, and then R7 is going to allow us to do the return value address and the next instruction address. So this is why we push R7 and R5. Then after that, we have to add in the local variables from the activation record. So whatever that's defined in the subroutine itself, that's going to go there. And then it's going to execute. So based on R7 that was pushed, this is going to store the return value. So it's going to use this to reference where it's going to update that value for the return. And then once we return it, then we're going to pop off. So whatever that's in R5 and R7 is going to get popped off. And then it's going to jump to R7 because we have to return that. Then it's going to load the value for the pops argument. So now we got to take these off. I'm sorry, the first part off, and then all the variables off. So it's going to pop off one by one. Remember last in, first out? So it's going to go through that last was added. It's going to get pop off. So the variable is going to go first, and then your arguments is going to go after that, get popped off. And then it's going to use R7, where the R7 has the address of the next instruction. It's going to resume back to the code for the next instruction, and it's going to execute that. Okay, so if I have another jump subroutine, it goes through the same process over again. Any question? So on the low level, you see that there are many steps that's involved in a subroutine call, right? When we do a jump to subroutine. And so the next time you write C++ or, Java, those type of programs, the higher programming language, you can think about what's happening when you compile the program, right? When the program is being compiled and executed, how stack grows and shrinks, how, it's able to go to different part of the memory to be able to retrieve or get it activate the record that stores the variable and the argument, and then how it retrieves the value to return and then pop that off. Any question? So I encourage you to take a look at the example. And this came from the presentation and also the textbook. So you can take a look at how, different part of the function call is implemented with the stack and how that's parallel with your LC-3. Okay, so the question that we just went over, you can find also the answer on page 4 and the top of page 5. That's where I put the notes. Any question regarding functions? Now, if you just use what's in the example in your project, right, keep in mind that these are snippets of programs or even part of the function. They don't show the entire thing. It's probably best to reference the lab examples so that way you can have a working program. I have some emails from students telling me, oh, I'm using this, and when I assemble, it's, yeah, because remember that these are also snippets. It's not a complete thing. So sometimes you're missing like fill and other areas. You didn't define what some of the registers were. So it's gonna throw error. All right. So we talked about subroutines and how it's called. Let's move on to pointer. So a pointer is a way that we can have an address of a variable in memory. Sometimes we would use a pointer to point to another location. A lot of times that's what we do, is we create an address or a variable, right, in C, and that's a pointer, and when we use that to point to different location in memory to retrieve value. Remember that your memory, when it writes, it's dynamically writing. That means that it's going to add values where it's available, right? So in the memory array, you would see that it's not always sequential, where we don't always put it on the next address. So the system is going to throw it in wherever. And to retrieve it quickly, we would need to be able to point to where that is, right? And that's how we can simulate the extraction of what we see with data structure. In the case if you're using linked lists or doubly linked lists or things like that. Basically, you're using pointer pointing to different section of the memory where the data exists. So when you're using pointer, it is indirectly accessing different variables. And so we associate addresses, right, to value this way. And as long as we can locate the address, we would be able to retrieve the data that's stored as values. So when you initialize a regular variable in C, let's say I say int x equal is 9, right? So the value is initialized for variable x. But if I'm using a pointer, simply I have a pointer variable that points to int x where my value 9 is stored. And I can use that same pointer point to other variables like w or y. So when we look at address and values, sometimes it's probably better that we think about how the memory would store, right, value in different parts and be able to retrieve it through pointing. So when we look at this example, we would see that register 2 contains the address of the first location, which is hex 3107, or I'm sorry, 3100. And the value for this is filled with hex 3107. So what we can do is we can use the register, right, which has a different address, and use it pointing to the variable where we initialize the value. So my variable is at 3100. So it's going to take that address and it's going to put it here inside register 2, and that's how it's able to point to the value. And if we need to read the value, it's just going to locate it through the address and be able to retrieve the value. So R2 is the pointer, and it contains the address where the data is initialized. Okay. So now we can talk about ways that we use pointer. We can use pointer to swap values in arguments. And so all that is ultimately we're swapping addresses for the activation record. And so when you're doing a running sum, or when you have a function that's ultimately updating values, right? So how does it know, right? Well, if your value is changed, what that does is pointing to the location for the updated value. Because all of this is in the swap memory, or what we know as a temporary location, where it's going to be able to store those values. Okay. So when you're looking at recursive function or things that would get updated throughout when that function is called, it creates a swap section where it's going to be able to point to the updated values from one to the next. And with that, we would need to really think about how the addresses are used, right? And how those addresses is part of your activation record. So when we put the argument onto the activation record, simply it is we are associating the address of the arguments, and as those addresses get updated with values, right, the location gets updated with value, that's how it's able to retrieve the updated values. Question. Okay. So with that, we can talk about number 5. In LC-3 program, how is pointer implemented and what does it contain? So in LC-3, we simply use a register and we point it to the address location. We would increment the memory location as pointer is used. And you would use load and store instructions to load the content and store the result between registers. And you would see this with store R0, R6, or R0, R5, right? So you do the store, or you can copy. So we simply use register to point to the address location, and we would increment memory location as pointer is used. And we would use load and store instruction to load the content and store the result between registers. And before we answer number 6, we want to take a look at it a little bit closer so you can see. Any question regarding 5? So on page 6, it gives you the example. In C, when you declare your pointer, you simply give it a type. So your data type goes first because this is a strongly typed language. Then you use asterisk and then your pointer variable name. And so now the difference between this and the reference, right? When you pointing, that's just a way to associate address. So you also need to dereference that variable, right? I know that you probably learned that in your C++ class. So when you're looking at, when we're using the asterisk and the P, what that does is it returns the value pointed to by P. But if you use the ampersand with the variable name, it returns the address. That's just a reference, right? So there's a difference. So if I want to return the address, I would use the ampersand, and then the asterisk allows me to actually return the value that was pointed by P. So when we look at LC3, this is the example. Int I, int, here's the pointer PTR. And then I is 4, pointer is going to be, right? When you do this, you reference I. And then we are going to do PTR is PTR +1. So it's going to read the content of the memory where the address is stored, and then it's going to increment. So on the right-hand side to your LC3, we clear register 0 because we initialize I for 4 here, right? We got to add that to register 0 and put it on register 0. And then once the 4 is here, we want to store I, so we store that. And assuming that register 5 is I, right? So we store that to register 0. So now we have I is 4. Then what we want is we want to now copy. So you would take I is 4 from register 5 and copy it to register 0. Now the store and the copy here, the store is the actual value. The copy is the address where that value exists. So when you add 0 to register 5 here, right, you're saying that it's the address of I is 4 to register 0. And then we store again with the subtraction. So store in pointer as we need to move downward 1. Then next, you are going to load. So you would take register 5, which has the content of what you're pointing, and you're gonna load that with -1 to register 0. So register 0 is gonna have your pointer. Then you are going to load the content to another register, which is register 1. So now we're going to load the content. So at this point, you're right here. Okay. And then we have to do PTR plus 1. So we're going to add the 1 and then store it again from register 0 to register 1. So when you look at this line right here, that's equivalent to what you see right here, right? As you see the comment. And then for the reference, that will be right here. And then for the initialize, this part is at the top. Okay. Any question? So that's how I put number 5 together. Any question? Then let's talk about number 6. For 6, we are going to look at pointer that's passed. So let's come back to the notes. So pointers as arguments, we can also put the pointer inside the parentheses as arguments like this for your function. So when you're passing the pointer into a function, that allows it to go to, right, what's being pointed, and that changed the memory outside of its activation record. Okay, because now what you see is that the caller passes the address of the variable that it wants in the function, it changes. So when we look at LC3, we would look at the register 5. We're going to add -1 to it and put it on register 0. So this is going to allow you to look at your value B, which is your second value. And we're going to push that. So once we push, we subtract 1 from 6, right? Because it needs to move down to the new value that's pushed. So R6, add it with -1 and store it and put it back, the result on R6. And then as you do that, you got to update it. So you have to store it. So R6, add it with 0 and put it on register 0. And then you got to do the next one, which is the first one. Remember that the last one, the second one goes first, and then the first one goes last, right? Because you want it to reverse the order as how you would pop it off. So then what you do is for the address of the value A, because it's a pointer, right? We're going to add 0 to register 5 and put it on register 0. And as we push it, we subtract 1 from register 6 and then store it again. So as you see the pattern, right? We basically point to the address by subtracting 1 from R5 and put it on register 0, push R6, store, and then repeat for both arguments. So when you look at that, your value A and your value B here, right? Value B gets pushed first because it's the second. And then value A gets pushed after that, right? First and second. So when we increment, it's going to move from the first to the second value. And so for the swap, you often also see it like this, value A and value B, right? The main wants to swap the values, value A and value B, so it would pass it. So simply when we do this, we are just referencing where that value A and value B is for our function. And so for the next example on page 7, you would look at like how new swap routine would be, right? So here it shows you how we would have register 5, and then you would load that with 4 for register 0. So this is going to be your first val. So it's going to point to 4 for value A, right? And then we are going to add register 0 with 0 and load that onto register 1. And as you notice the load, you have the address, which is going to point to 3. And then we want to associate it, temp val is being pointed by first val. So we would then take that because we loaded here, we're going to store 4 here. So we store 4 with register 5 to register 1. And then similarly, you would see that using other register for the second value and the first value. So when we swap the value, 3 is, 3 is first, 4 is second. Now we want to switch it. 4 is first and 3 is second. What you do is you would load, right, the 5 to register 5 and put it on register 1. And then for the register for 0, load it to register 1, from register 1 to register 2. So now it's going to update the address for what that value 4 is, and then store it. So there's no magic way or anything when we swap values. It's just a way for it to update the addresses in the memory by swapping the addresses with the register. Ultimately, that's what it is. Okay, so we can answer 6. Why should pointer be passed in a function in C? It allows the function to read or change memory outside of the activation record, because recall that it's only going to add the activation record that has, whatever the argument is and the local variable. So when you're using the pointer and you're passing the pointer into a function, it's going to read it from outside of the activation record because we're using another memory address that's pointing to our argument. So it's going to use a separate memory location and pointing it to what's on the activation record. Question? Okay. So if we're good with this, we can talk about null. So null is used quite a bit. Null is when we don't initialize anything yet for the pointer. I see it when I teach data structure, I see it all the time, right? You see it in programs. So we already talked about how we can create a pointer, right? We declare a pointer So in this case, you can have a pointer variable, but then you want to put null, and null is predefined in the macro where it could contain a value, but it would be often that the address would be 0, right? But you can't have 0 because 0 is not a legal address. So they have to find a way to put like a holder. So think of it like a placeholder for address that we can update throughout. Okay. And so for your argument, what you see is you can pass the address of that variable and you can have multiple results. So it's going to return from the pointer, and it's also going to return the status code for the function that's a result where it would update the address throughout. Okay. So this is a way that we can have a placeholder where we can later use for the address. And then here kind of show you some basic C things about creating your pointer, dereference your pointer, reference your pointer, and so on. So for number 7, I ask you, what is the purpose for no pointer in C programming? So ultimately, no pointer is declared when the address is not yet assigned or the address is unknown. Like I said, it's a placeholder for address to be used down the line. You would initialize a pointer variable when the pointer variable isn't assigned any valid memory address yet. Kind of like just reiterating the first bullet, but you would use this. I should add a no pointer. So you would initialize the no pointer variable when the pointer variable isn't assigned with any valid memory address yet, right? But we can't use 0 because 0 is not valid address. And for no pointer, it would, to check the no pointer before accessing any pointer variable, by doing so, we would perform error handling in the pointer related to the code by dereferencing the pointer variable only if it is not null. So you can only dereference pointer variable if it is not null, because in null, there's nothing to dereference. There's no address to dereference. So you can only dereference regular pointer variable. So for null, right, we cannot dereference, and we would need to check the null pointer variable before accessing any pointer variable. And also we can use it to pass into a function as an argument. So to pass no pointer to a function argument when we don't want to pass a valid memory address. So you can use that, right? Remember that it just holds potential address. So you can pass it into the argument if you yet to have any memory address. So it does create that location, right? Or it would potentially associate that location using the no pointer for the argument. Questions? Okay, just a little bit more to go, and then we'll wrap this up. So since we talked about that, let's answer number 8. In C programming, what is the difference between when we're using asterisk and a variable name like var and the ampersand var, right? So you would use the asterisk var for decoration of your pointer, and the ampersand var is for reference. Pointer needs to be dereferenced with the asterisk to access the memory location that it points to, whereas reference can only be used directly. Any question? I'm sure this is review for some, right? Might be a little bit of new information for others, but I think most of you already took C++. So you've probably seen this many times. But understanding it clearly is going to help you understand it from the low level. Okay, so in the next bit, we're going to talk about arrays and how arrays define in C compared to LC-3. So for C, we would use array as a container that we can have a list of values. So you can have a group of values, and sequentially we can access each value by its index, starting with 0 as the first value, index 0 for the first value, and go to however many that you would have. Now for C++, you would see that normally you would initialize the array with its size, but there are ways for us to use dynamic array, right? So arrays is often used to store multiple values. So in C, we would type the container, so the data type goes first, and then the name. And then inside it, you would initialize your elements or the number of elements. So you would have, let's say, 5 elements, you would put the 5 there. And then when you need to access individual value inside the container, you would use its index. So now array as the container, when you look at the array, because it's storing sequential values in as a group, and think of it like a list from the beginning to end. And in Python, that's what we call list, but there is library for array. But you would see that array elements are allocated also in the activation record if you're using array for your function. So when you look at this, if you say int grid is, we have 10 elements, we would see that you would have the first element starting with grid 0, and it's going to go to grid 9. That gives you 10 elements. So array, because it needs to access it sequentially, they are stored together sequentially. And so if I need to retrieve my first element, I simply use its index 0, which is going to be the lowest address in the memory space because it's first. And as it goes, I'm going to increment the address. So the next value at grid 1 is going to be higher in address than grid 0. And so when we look at LC3, right, we would have, let's say that I want to do X is, right, the second element, I'm sorry, the fourth element plus 1. So what you would have is you would need to first reference where the first one is, right? Because if I need to access the others down here, I need to know where to start. So in the low level, you have to know where is the first element. So in the code, what you see is it's going to, we are going to take -9, because remember that 0 through 9, right? For the grid, we're going to add -9 because we have to go back to where that 0 is, right? To register 5 and then put the result on register 0. And so from there, we know where our first element is. Then we're going to load 3 to register 0 to go to grid 3. Okay. And load it onto register 1. So register 1 allows you to access grid 3. And we are going to do a +1. So add the 1. And then we are going to store -10 to register 5 and put it on register 1. Why -10? It's because 9 plus 1 is 10. So you have to subtract. So that section of the memory is for the array, right? So you have to subtract 10, right, from register 5 for the grid. So your X is going to be at R1. Okay, because we last added 1 to R1, and then we're going to store R5 with -10. So this cuts up the section for your array. So where X is grid 3 plus 1. Now, if we want to initialize 5, right, for your 7th element, which is grid 6, what you do is, again, if assuming that you already go to your grid 0, right? So we clear register 0. And then what we're going to do is we're going to take 5, we're going to add it to register 0. And then we're going to place that, right? Or subtract 9 from register 5 and put it on register 1. So this is going to reference your first element. We always want to subtract 9, right? To know, because there are 0 through 9. So we're going to subtract 9 to go to grid 0. And then we're going to access grid 6. So you're going to store 6 to register 1 and put it on register 0. Okay. So the 5 here is initialized already in register 0. So you already have 5. Then you need to reference where grid 0 is, and then from there you move to grid 6. Okay. And so you can take a look at additional example. So we can take, grid X plus 2. So we bring X in. We got to know, because X we already defined previously. And then we subtract 9 for grid 0. And then we need to move to grid X. So we have to reference grid X, load, and then add 2. Okay. Because we add 2 here. So you can take a look at the mechanism on how we access different values in the array and use the register to load and store. So let's answer the next question. So for number 9, it's asked you, how in LC3, how do you create a 10-element array? You would use the registers to point to the first and the last index of the array in the memory grid. And you would increment by adding 1 to increase the memory grid for each index. So if I'm going from 0 to 1, you simply do a +1, right? but you have to think about the number of your elements in the array. And that's what you're going to use to cut up your grid. Okay. And then to go from a certain index to the next index, because they are sequential, as they're stored from one to the next, we're going to increment one. But I encourage you to take a look at the example that's provided in the notes and go through each step so you can understand how that is for accessing certain index, right? Using a variable as indices, or reference variable, that is, right? Or initialize values for a certain index and so on. Okay, any questions? I think we had extensive amount of exercises in the lab for your string, but you can, like for those people who are doing character counters, this section also can be important, right? You can think about your string in C as an array of characters. And similarly, you can use that in LC-3. Remember that we can also we can define strings with null terminated. So when we compare the array versus the pointer, array, it is essentially a pointer. We need to point it to the first element of the container. So when you declare an array in C++, all that is you telling the compiler that, oh, I'm going to have a container that's going to store this many elements. And so what it does is going to take a section of the memory, it's going to create it for that number of elements, and it's pointing to the first element address. And so when you initialize the value, so I can have, my array is 1, 2, 3, 4, 5, right? So it's going to store 1 to the first address, and then it's going to increment after that to store the sequential value in your container. And that's how it works. So in the next page, it talks about how you can work with strings in your in the word size. So we'll touch a little bit on this. Okay. Now the pitfalls for the array is that overrun the array limits. Sometimes that can cause runtime or compile issues. And so in the case of where like I'm looping, you see this a lot with the array. It's probably better that you would use a function to be able to set up your array and be able to access it, because even with running sometimes that you see that when we're dealing with a lot of data, sometimes your data can take a while to compute because it has to reference in memory locations that's temporary. So your performance is jeopardized. So it is better that you chunk it and to be able to kind of make it independent by writing your variable and creating container to store things temporarily. So that way it gets on the activation record and it gets on the stack. And so it doesn't have to retrieve it from different areas. So ideally that is suggested, right? I see a lot of projects that my students do in 7 and other classes, right? They just create an array and then they would loop through the array to output values. Yeah, for a basic program, that's okay. But when you're dealing with more complex program, you should think about how you would use function, and think about how your space and time plays a role with your data structure, especially for OOP design. So, and that kind of tap into 17C, but you have to think about how you can make it a little bit more independent and using that because it's part of your activation record and stack, versus just writing things locally. And this is, iterative type of execution is really depending on the number of input anyway. So if you have lots and lots of input, your performance is jeopardized in the program. Okay, so that's something to think about. Okay, so here it talks about address calculation. This is the next question, and how that can be dependent on the size of your elements, right? Like I just mentioned about the number of inputs, because it needs to kind of set up like how many addresses in that area that it's going to create for your array. So when we looked at specific elements, we have to really go to the first elements and then go from there to go to the later elements. And now the type of data is important in C-based language, right? Because for strongly typed language, that's really allocate the size based on the data type. So when you're working with int, so in this example, what we would see is that we would add a certain number to the base address. And so that's how it's going to be able to address it, by adding the value, right? Earlier, you answered the question, you said that I would increment based on the number of elements in my array. So when we're accessing the fourth element, we would add 4 to the base address because we are going to that index. Now, when you're typing double in C, basically you would take that value arithmetic wise and you would multiply it. So that will be 4 times 2 because it's double the size for the fourth element. Okay. So for C, the compiler does the calculation and it's really depending on initializing the number of elements that you have in your array. So this is why, like, some of my CIS11 students, they always email me like, oh, I'm trying to write the dynamic array, or I'm doing one of your lab exercise and I didn't put in a value in the square bracket and it's throwing this error. It's because Visual Studio, traditionally, when we initialize our array, we have to tell it the size, because the compiler referred to the data type and the size of the array to chunk up the memory that used to store the values that's going to go into that array. And the IDE, it's created to really detect that kind of error. So in the case where if we're just writing an array and we don't give it a size, it would not know how to create that section. Now in the dynamic array, what we do is we would use a variable and potentially it would have some kind of size as your array grows, right? So my array can have 3 elements at one point, but then eventually it can grow to be 300 elements. So we would have some kind of container to be able to say, oh, this can be updated as we would initialize the value for the dynamic array. So in this case, what you see is the data type plays a role in how it chunks up that memory space to be able to store the value, because potentially the double value is larger in size than what you see with character and integers. Okay. So let's do some calculation. So if your base address for your array is at hex 31F0, right, as allocated a word for each of the elements. So that means that we're doing 16-bit for each of the element in our array. What is the address of the sixth element of the array, right? So we need to increment from here. That's going to be our index 0. And we need to go to the sixth element. You can refer to the slide if you download the slide. This is on slide 28 of chapter 16 presentation. But just to save you the trouble, I wrote down some of the steps. So you need to really look at the size, right, of your array. So the address calculation depends on the size of the elements. In LC-3, we assume that one word is per element. So it says that in the question as well. So 16-bit per element. So to find the sixth element, which is index 5, you add 6 to the base address. Okay. So, yeah. And then for the 6, it's going to be at F6, and then the 7 is F7 as we start with F0. So if you're asked to find the 10th element or the 100th element from a certain base address, you just know that it's going to increment to that. So you just do the arithmetic addition, right? You add the index to that. Zero, 1, 2, 3, 4, 5. Any question? So when we do the double type, right, you would do, that will be hex 9, 10, 11, 12, B, C, so C. So if it is double type, then you would add hex C to your base address. Now, if you use the base address hex 31FA and you are allocating double words, so you're going to multiply by 2. Okay. What is the address of the fifth element or the fourth? I'm sorry, the fifth element, which is index 4 of the array. I think I corrected this last semester. Let me think about it. So 0, 0, 1, 2, 3, 4, 5. So that is the sixth element. We add 6 to the base address. I think you add 5 because it's at index 5, 0 through 9. Yeah. So let's correct this, you guys. I had it correct at the beginning. Sorry about that. F5 and F6. The reason why is when we start at 0, right? When we count index 0, so it's here. 0, 1, 2, 3, 4, 5, right? So index 5 is at the sixth element. So you would add hex 5 to this. So it will be at hex 5. And then the subsequent one, because so use the index when you add. And then for this should be 8. Because you're going to double the hex 5, which is 10, right? 5 times 2 is 10. So that's hex A. And then that will be at hex F10 plus hex A. So if you start at hex 31FA as the base address and you're doubling the word because we're going to the 5th element, that's index 4. So you take hex 4 times 2, you get hex 8. And so you would take hex 8 added to the hex 31FA, you have hex 3202. You can put this into your calculator to check if you like. So how can we do this, right? We can fill it, right? Your 5th element is at this and this. But if you fill it with data, what will happen is you have to tell it where is the base address, so that way we can increment. So to make it double word, right? If we want to have a very large value for that particular index or that particular array, then you would need to use 32-bit, which is 16 times 2. So when you type your data as double, what that does is it's going to double the size for each of the element inside your array, and your array is bigger than your int or your char array. And I'm sure you know this when you learn about data type, but just to reiterate. Any question? Let me zoom out a little bit. I think some of you are still trying to record answer. Okay. So final exam questions, you will come across base address questions like these for array. It will ask you a certain base address, and then you need to calculate the address for, just focus on where the index is and the size, right? That will determine your arithmetic and where the element address would be. Okay. So on Tuesday, I will not hold class again as I am going to a conference with some students. I plan to cover what's left in the class on Thursday. I will turn on your final review. Actually, next week, I will turn on your quiz 3. So work on the quiz and the practice quiz. And then I already have the final review recorded. If you want, I can turn that on so that way you can cover it. But on Tuesday, there will not be Zoom session. I do plan to Zoom on Thursday, so I will put notification in Canvas via announcement and also the module itself so you can see. As I would get back earlier in the day on Thursday. But if you have questions or concern, and I will try to catch up with your grading sometime this weekend and going into next week, please let me know. Okay. All right. So let's stop recording.